MuleSoft Meetup channels, and also by request I can share individually the records. And let me welcome our speakers for today's session. It's from API-led to agent-ready migration to existing MuleSoft integrations. We have two speakers from Synergysoft, 𝐷𝐸𝐻 Subotin and 𝐀𝐏𝐈-𝐋𝐞𝐲. And the topic is really, let's say, actual for where we are now in context of AI agents, MCP, servers, and all the relevant topics related to AI agents. Many companies already invested in API-led integration architecture and based on MuleSoft, and MuleSoft is offering great capabilities to evolve your current API-led integration, being ready for AI agents, building agents, governance of AI agents, building MCP service, making connectors, and etc. We will, during this session, we'll go through the main concepts and approaches, how to adopt your current API-led integration, MuleSoft based, like MCP ready, agent ready. We will have a couple of practical cases and also Q&A at the end. So I'm passing the word to Artyom. Artyom, please go ahead.
Okay. Hello, everyone. Thank you for intro, Maxim. Yes, so before we'll start, I just wanted to say that sometimes screen sharing can stop working. That's why just let us know about this, and we will quickly resolve this issue. Okay, I believe we're ready to start this session. And today we will cover a very hot topic. It's an MCP. So I assume that everyone here familiar with API-led connectivity approach, which has defined as a paradigm how enterprises integrate systems. MuleSoft gave organization a structured, reusable approach like system APIs, abstracting backend complexity, process APIs, encapsulating business logic, and experience APIs delivering tailored data to specific customers. And this all governs through the Anypoint platform, catalog in Exchange, and secured through API Manager. It was right architecture because the consumers were always predictable, like developers, applications, partners, third-party systems, and so on. But the main thing here is that consumer is changing. And AI agent, it's a new consumer. They don't browse Anypoint Exchange at all. They don't request client ID or read RAML specifications. They receive a goal in natural language, reason over available capabilities and runtime, and autonomously compose a sequence of actions to get there. They don't need endpoints. They need tools. Specific capabilities described in business terms, understandable by reasoning model. And this shift doesn't make your existing investment obsolete. It's a main thought which I will try to bring across our session. So this shift makes it the foundation. Every experience API already aggregates the data for a specific consumer. Every process API already extrapolates the business logic an agent needs to act. Every system API here already abstracts the different systems like Salesforce, different CRMs, ERPs, and so on. And these three layers are exactly right. What is missing here is the translation layer that makes them legible to an agent. And that's precisely what MCP provides. So basically, what is MCP, how it works, what is the main core components? Let's discuss this. MCP was introduced by Anthropic in late 2024 and has since become de facto standard for connecting AI agents to external systems. For MuleSoft customers, think of it like a missing protocol layer above your API-led architecture. Like we will discuss the API-led strategy with MCP a bit later, but just for now, it's a layer top of your API-led architecture, one that any agent from any vendor can use to discover and evoke capabilities exposed by any MCP-compatible server. From some of the MuleSoft workshops, I noted a good comparison. Like MCP, it's USB Type-C of AI, universal standard connecting agents to the systems and data they need to act. And it's really true. MCP defines a simple but powerful interaction model. An AI agent running inside an MCP host such as Claude, Agentforce, GitHub Copilot uses an MCP client to communicate with the MCP server. In MuleSoft's implementation, that server is either a MuleSoft application built within the MCP connector or an existing REST API wrapped by MCP bridge through Omni Gateway. It's the main two approaches, again, which we will discuss a bit later, but just for overall understanding that MuleSoft right now provides two of them, or like MCP connector and MCP bridge. The server exposes capability and the agent decides which ones to use, like in what order, with what input. And this happens in all runtime without any hard-coded integration logic. So if we're talking about the structure of the MCP or MCP core components, in other words, there are three main core components. It's a MCP host, the AI application that coordinates and manages one or multiple MCP clients. MCP client, of course, the second one, a component that maintain a connection to an MCP server and obtain context from MCP server for the MCP host to use. And of course, the main part, like translation layer or brain, let's say like this, it's MCP server. This is honestly fundamentally different from the understanding of the REST API calls. And there is no predefined integration contract between two engineering teams. Like the agent reasons dynamically, discovering tools at runtime the same way a developer wants browsing any point exchange, for example, in milliseconds. There are three main points that MCP server exposes. The first one, I've already mentioned it, it's tools. It's invocable functions the agents call to make an action. It's an equivalent of post endpoint, for example, but it's described in natural language, so the agent can understand what the operation means, but not how to call this action. So in MuleSoft internally, this map directly to your Mule flows. But again, this very important thing to understand that it's really described in natural language. We will see it later. And agent does not understand how it's working under the hood because it's just running the natural language action. The second one, it's resources. Data resources the agent reads to build context before acting. It might be different product catalogs, customer records, order history, or other documentation. In MuleSoft, it might be your get-based experience and process APIs. They're already built, already governed, now accessible to agents as a context input. And the third one, the last one, it's a prompt. I believe you already heard about prompts. It's an instruction, might be reusable instruction that shape agent behavior in specific situation. Like it's useful for standardizing the compliance language, maybe domain-specific tone or decision logic consistently across every agent that touches your MCP server. But also there is one more. It's not the real fourth one, which we just review it. It's additional parameter, if I can say like this, which we need to touch. It's a transport for the MCP. And basically, MCP protocol supports two transport mechanisms. The first one, it's a simple standard input-output stream for direct process communication between local processes on the same machine. The main point here is that it's providing the network communication only locally. Like that's a main disadvantage of this approach. And the second one, which is used across all the MCP APIs, agents, and so on, it's a streamable HTTP transport mechanism. It uses HTTP post for client-to-server communication with optional server-sent events for streaming capabilities. This transport enables remote server communication and supports standard HTTP authentication methods, different authorizations, maybe just bearer tokens, and so on. And as a subpoint for streamable HTTP transport, there are again two subpoints. The first one is a pure streamable HTTP. It's well known streaming updates in the same connection. It supports multiple agents. And honestly, with our experience, it's the best solution for the MuleSoft. While the second subpoint, it's SSE or server sent event. How it works? It consistently keeps the connection for the updates, for other notifications. And due to this, it can lead to the any kind of issues. That's why the best one here is to use a streamable HTTP transport mechanism. So this is the main points you need to know about the MCP, like the high-level overview. And let's move forward to the current workflows of MuleSoft integrations, because we started this topic with discussion of API-led connectivity approach and how it can be managed within the MCP. But of course, it's not the simplest one. Like there might be bottlenecks, and that most enterprises running the MuleSoft today have invested years building a structured integration landscape. These three-layered approach, system, process, and experience, it was developed, governed through the Anypoint platform. It's ready to be reusable. And the main question you can ask that it's going away. What to do with this? But the real answer is not. It's not going away because it's an asset. But of course, there is a reasonable gap. Like every one of those APIs which was designed with the human or an application approach as a consumer, the contracts are written in OpenAPI, for example, or RAML. The flows also are written by the developer. The error messages, for example, for specific use cases were written for the UI interfaces or to be written to the log files. But all of this was done, not to the AI agents. And we need to understand what to do next. When the agent encounters your experience API layer, it sees HTTP endpoint. That's a most common case. But from technical standpoint, it doesn't know what the operation means. For example, we have just a GET request, and even if it has not very appropriate naming convention, it's really hard even for human to understand what the data it needs, what it should do with the response, how to handle the edge case. So there is no semantic context under it, no tool description, no natural language guidance. And how you can understand all of these issues can be solved by the MCP. If we're going through the API-led approach, let's review step by step what is missing on each layer. For example, experience layer. It might be most common mobile application, a web interface, or like partner APIs. And all of these APIs are the closest APIs to the agent ready, because they are already aggregating and simplifying the data. But the main gap here is a lack of tool descriptions and most probably agent-friendly error handling. The next layer, process layer, it's your orchestration APIs like order management, inventory, and so on. It's contain exactly the business logic agents need to act, that's for sure. But agents can't discover or reason about them without MCP wrapping. So they cannot directly access, they can access, but they will not understand anything in this business logic, which is under the process API layers. And the last one, it's a system layer. It might be Salesforce, SAP, and other third-party systems which we are connecting from the system API levels. So it's a source of data truth and solid foundation here, but completely invisible to any agent without a process or MCP layer above them. So we cannot do with this API without wrapping within MCP. And here we are getting a good news. So you have this integration in place, and you don't need to rebuild it from scratch. You don't re-architect it. You just expose this integration. And MuleSoft gives you two paths to make your existing API-led approach agent-ready without touching a single existing flow. So your APIs are already half there. MCP is the last mile. And on this, we are just switching to the most interesting part. I've already mentioned that there are a couple of approaches for handling MCP using the MuleSoft. Again, we just noted that there is no necessity to start integration from scratch if you wanted to implement MCP. You just need to choose the correct approach for your particular situation. MuleSoft gives you two different choices or design patterns how to do this. But at the outcome, they have the same result. Like AI agents can discover, understand, and invoke your business capabilities through MCP. That's the main goal. The difference is how you get there, how fast, how much control you need to do this, and how much control you need to allow for your agent. But in fact, these both approaches can be used in parallel. I will show it to you this real use case later, but like starting from the bridge, MCP bridge for speed, then rebuilding strategically with the MCP connector, because it matters most. And the first part, as you can see, it's MCP connector. We will start from the complex one, honestly, because imagine such real scenario, like on the screen. You're building a retail company is building a new AI shopping assistant from scratch. So there is no existing checkout flow, for example, to adopt, no any legacy implementation which we can wrap. And customer needs to interact with the assistant and type in a natural language the request. You can see this request on the left side. Just wanted to give these two pairs order to the specific place without any additional steps. And what will be next? You don't want to communicate with any kinds of forms. You don't have checkout flow, no manual steps to do this. And AI agents take it from the start point. Then MuleSoft handles everything behind it. And then customer receives a correct answer for his request. So this is a main scenario, if I can say like this for the MCP connector. But of course, the details can vary, depends on the situation. So this is not about honestly making an existing integration agent ready. So it's about building the integration specifically for an agent to use. The distinct matters, and it's exactly why MCP connector is the right choice here. Let's review step by step how it works. The first one we already discussed, that's customer just type his request in the chatbot, for example. And this time, an AI agent running on, for example, Claude, Agentforce, any compatible LLM, the agent reasons about the request. It understands which actions should be performed and passes these actions to the MCP client embedded in the MCP host. The MCP client sends a structured tool call over the MCP protocol to the MuleSoft Anypoint platform. So we're at this point. Anypoint platform in this particular case is not playing any role. It's just a place where we can deploy our MCP API. You see that we have additional MCP API on top of our API-led integration. MCP client and MCP server communicates within MCP protocol. We already discussed the transport mechanism, how it can be done. So finally, the request arrives to the MCP server. It's a Mule application built with MCP connector running inside Anypoint platform. It's not a generic proxy. It's really a place where this API is being deployed. It's a purpose-built MCP server that understands the retail domain, in our case, use case, with name tools, precise descriptions, defined input schemas, customer handling, and so on. The agentic MCP API here, which we have, acts as the single entry point for all agent tool calls. What's happened next? Next, MCP server routes the agent's intent through the experience layer, like shopping API, mobile API, and so on. This layer aggregates and simplifies, translates the agent's high-level goal into instructions, and send it to the process layer using the REST API, simple REST API calls. At this point, agent never needs to know which downstream APIs will be called, because for this part, MuleSoft is responsible. The next, like we will not discuss the part of the process layer, system layers, then third-party or backend systems, because I hope everyone here is aware how it's working. What's happened on the another direction when we successfully place an order? Then MuleSoft returns the tool result back to the global chain through the MCP server, to the MCP client, to the LLM finally. The agents then compose a natural language response because that's what customer is awaiting. So in this way, agent should reply like, I've placed your order for required items, like estimated delivery time will be 3 business days, and of course, order number or order reference. That's what user want to see. So the main chain looks like the user asked, the agent acted, and under the hood, MuleSoft made it possible. And here we should discuss why we choose MCP connector for this particular use case. Why not the second approach, which is called MCP bridge? So first of all, it's a new build. There are no existing REST APIs to wrap, no inherited endpoints to map. So the integration is being created specifically to serve an AI agent, which means every architectural decision can be made with agent consumption to mind from the start. That changes everything about how the integration should be built, because the agent is not calling a single REST endpoint. It's triggering a multi-step workflow across different process, different system layers, and of course backend systems. We just reviewed this approach. So the tool descriptions need to be precise enough for the LLM to call different services for the first time without any ambiguity. And the error handling needs to be agent aware. If stock is unavailable, the MCP server must return appropriate message to agent, not like 404 or something like this, which will be really not understandable for the agent. Another point, that authentication logic must handle session state across a multi-turn agent conversation, where the user might just stop the discussion in the mid-flow. That's also possible. And none of these points can be achieved using the gateway proxy or just MCP bridge. So it really requires a native Mule application. In our case, it's a dedicated MuleSoft API placed on top of the API-led approach. And this API should be built with intent using the MCP connector, where every tool name, like every description, every input schema, and every error response is designed for a reasoning model, not for a developer like it was before. And now we are at the point where we can show you the first part of the demo. Of course, it will not be a real retail scenario, but let me switch to the Anypoint platform. So we have a trial account just registered for this session, and I would like you to show our runtime manager first of all, just to be aligned with you what will be showed. Okay, it's loading. I hope. Yeah. So what we have here, we have 3 APIs under the API-led connectivity approach. It's experience layer, process layer, and system layer. All of them are running on the Cloud Hub 2.0 and latest runtime version. And we have one more application. It's MCP API. You see that we not put any layer postfix for it, because for standard for according to our thoughts, it's placed on top of the API-led approach, because it's completely different rules, permissions, and set of the operations which will be performed under the MCP API, even in this particular case. So what is happening inside the MCP API? For this, I will show you some technical background. You see right now I'm in the Anypoint platform. And let's quickly go through the internal structure of the MuleSoft API. So we have global configuration file here. Like this API is also written according to the best practices suggested from the MuleSoft. That's why you see different packages and so on. So for the global configuration file, the most interested part is the MCP server here, because we installed MCP connector, MuleSoft predefined MCP connector to this API. Connection type or transport mechanisms, we already reviewed, and we are using not the SSE server, which is I believe outdated already. We are using streamable HTTP server. Then we have several configurations like listener, MCP endpoint path, and that's it. Like also MCP name, MCP version, which is placed to the property, but it's not real interest for us. So you see that a configuration of this MCP connector looks very simple, well, like similar to the Salesforce event listener, platform listeners, or something like this. So it's just the same type of the configuration. Then what we have? We have a main file where we placed just one flow for the session management, because we need to create new session for each request coming from the MCP client, and then close this session. And then we have a main part. Main part of the MCP API is tool management. So you see that we have tools, different tools for our specific use case. Just briefly, we'll try to explain our use case. We have a cloud database which contains several details about the some of the racing PC racing game. And we have different entities there, like players, teams, races, and I believe that's it. For others, we have additional like extensions, race results, player results, and so on. But you can see on the screen that each of these tools has a separate MCP server tool listener, which is configured for this particular entity, for the players, for creating players, for getting players, and so on. Under the hood, still it's a reference to the simple MuleSoft flow, which will be, let's say, a proxy to our experience API. So yes, I will go to the implementation part. For example, we have get players, and you will see that in this file, hope it will open. Just 1 second, it's loading. Yeah, so for the get players, we have a flow for implementation this request, and you see that it will be a request for the experience API. So it's nothing more than simple request, because under the hood, the main goal of the MCP is to explain, is to understand which request exactly it's necessary to execute while receiving instructions from the agent. That's the main goal. That's why here we have just AI tool naming, which is very important. And then according to this AI tool naming, we are transferring the data to the experience API level. So that's pretty much it what we have here in the MCP API. And now I see we have not so much time. Let's try to cover the demo part. So for the MCP connector, there are two possible ways how to establish the connection between the agent and, in our case, backend system. The first one is to use direct connection from our agent to the MCP API. So each MCP API will run under the dedicated public endpoint. What I am doing, I'm just copying this endpoint, public endpoint, and going to our Q.O.D.E. So for this one, how basically we can connect Q.O.D.E. with the MCP server. Previously, on the oldest versions, it was necessary to just configure the text file of the configuration of the Q.O.D.E. configuration, but now it's much easier. What we need to do is just to go to the customize connectors and add our connector. So we will add custom connector, and I will name it like MCP connector first. For the remote MCP server URL, I will add the public endpoint of the MCP API, and what is very important, add MCP at the end, because each MCP server runs with the base path like MCP after the main URL address. So I am pressing on the add button, and yes, you see that I've just received all of the tools available under the MCP API. So all of them were retrieved from the communication between Q.O.D.E. and the MCP server. I can quickly try to request something from my database just to show that everything is working as expected. Just show all available races. Let's wait a bit. You see, the first step is to find appropriate tool, because as I said before, the main part is to give this understanding which endpoint should be triggered in this case. But you see already that some data is coming, and if I will go to this demo MCP API in the logs, I will see that the request is going through the MuleSoft demo MCP API. It means that everything is fine. We are good at this point. And the first case of the creating MCP server using the MCP connector is being covered. The next one is most, I believe, common, or it will be more common in the future. It's running MCP connector or MCP API under the gateway. In our case, it will be Omni Gateway or previously Flex Gateway. So what I need to do, we have already predefined or managed Omni Gateway in our trial account. Then what I need to do, I need to go to the API manager. Okay, Q.O.D.E. is still running. And for this one, I will just, again, goes to the connectors and remove this configuration. Okay. API manager still loading. Again, let's try one more time. API manager. Okay, finally we are here, but here at this point we will not create an additional API instances. We need to go to the agent and tool instances, and here we have a couple of settings: MCP server, MCP bridge. In our case, when we are looking for the MCP connector, we need to choose MCP server because it will be MCP server using the MCP connector. We are choosing Omni Gateway. We don't have previously registered MCP server. That's why we will choose create new one like MCP server test. Okay, it's already exists. It will be test one. It doesn't matter the name, honestly. Then what will be the next step? Next step, it's just downstream configuration. We are not changing anything here. Going to the next part. Yes, here what we need to do, we need to update upstream URL. Upstream URL, it's a URL of the our MCP API. It might be not only single API here, but like in our test purpose, we are just adding, you see, demo MCP URL, which we just choose for the testing connection between Claude and MCP. Upstream label will be like MCP API, and that's pretty much it. Creating. So let's save this and deploy to the Omni Gateway. Of course, it takes some time, but in general, we received that it's already somewhere in place. Still, maybe some additional configuration is done under the hood. But what we can do for testing this part, we need to go to again back to the Omni Gateway or Flex Gateway and choose the Flex or Omni Gateway URL. It's not so fast today, but yes, so we have public endpoint. What we need to do, we need to copy this URL. We need again to add custom connector. It will be MCP connector, the second approach. And again, we need to add this path like MCP, add them, and see what will be at the as the result. Again, we are getting all of these tools in place. It means that if we receive the set of tools, then we will be able to get this work. I just not want to spend some time requesting the same data, showing some details from the database. But important point here. Yes, we have our MCP server using the MCP connector in place, but we need to apply some default MCP policies. About the policies, topic we will touch a bit later. But to successfully run the connection between MCP server using the MCP connector, we need at least one default policy called MCP support. Sergey will later go through all of the policies and say which of them are default and which not. But at this point, we covered two different use cases for the MCP connector. Like we established the connection to the MCP server directly to the MCP API or through the Omni Gateway, which is more like the best approach is to connect using the Omni Gateway because you have more control, more security, performance, and so on. Now we're getting back to our slides. So, not this one, sorry. Just going back to the, yeah, I hope you can see my screen. Going back to the MCP bridge. So, at this point, MCP bridge, you have already for example, REST APIs running in production. They're all of them registered in Anypoint Exchange. They govern through API Manager. And MCP breach delivered through the Flex Gateway, Omni Gateway, wraps those APIs as MCP tools in hours, really in hours, without touching a single line of existing code. You just select the API instances, map HTTP methods to tool names, add descriptions, and deploy. And Omni Gateway will handle the rest, including inheriting all of the authentication, rate limiting, and other policies. So what concerns the real scenario? Just at this step, forget about the retail use case, which we discussed before. Here we have pretty same, but different from the main perspective use case. A major retail company acquired a competitor 2 years ago. Imagine this one. And the acquisition brought 40 REST APIs, product catalog, pricing, inventories, and so on. And all running on the acquired company's MuleSoft instance. So it's, let's say, not legacy, but already existing integration. The code base is partially documented. The original engineers which developed this integration moved on. So rebuilding is off the table. It's the use case. But the business wants an AI shopping agent or assistant, which will be live in like 6 weeks. It's possible. The customer request is the same. I just wanted to get these 2 pairs delivered to the London. That's pretty the same. And the same step is like to the MuleSoft MCP connector. The user's message reached to the MCP host. It might be Claude, Agentforce, or any other compatible AI agent. The LLM reasons about the goal. The MCP client formats the tool call and sends it over the MCP protocol. This time, the destination is not the Anypoint platform. Instead, it's an Omni Gateway, and it's not a custom application. You see that we have just the legacy, the old API-led structure without any additional MCP APIs. And this is like MCP breach is the architectural heart of the this MCP server. There is no agentic MCP API as it was before. There is no new application again. Omni Gateway, it's configured with the MCP breach, is itself an MCP server. It receives the tool call, looks up the mapping configured during setup, and translates it into standard HTTP requests against the inherited REST APIs. So no needs to understand the acquired code base. No needs to modify it. The mapping is configured in API Manager by someone who understands what endpoints do, not how they were built, and that's it. And then the way is pretty the same. We're going through the experience process system layer, and at the result, we are getting the same outcome. So we need just 6 weeks reduced to like even days, because no code-based findings required. And why especially this scenario works with breach? Because MCP connector would require building a new Mule application, which means understanding the acquired APIs well enough to replicate their logic in native flows. Now, that's months of work because nobody owns the code base. MCP breach requires only understanding what the endpoints do and mapping them to meaningful tool names. That's it. In this scenario, breach was designed not as a shortcut to connector, but as the only viable solution when rebuilding is not an option. But just a really important point that MCP breach complements. It's not replaces the custom MCP server approach. So when you need a custom orchestration logic, build a dedicated MCP server. But when you already have REST APIs and want them agent ready instantly, MCP bridge will be the fastest and safest path, of course, because delivering AI integration with zero code changes and zero disruption to what already works. So for demo, for MCP bridge demo, it's a part which we need to go through. Again, we have this Omni gateway because MCP bridge will not work without the MCP, without Omni gateway. So what we need to do here, we firstly, we need to go to the Anypoint Studio again. And we have this experience API because initially you see that there is no any additional API between Omni gateway and experience API. And in our case, the same approach. We just have Omni gateway and experience API. Experience API with the just endpoints which describes and which were developed firstly for the APIs, not for the agents. So you see that we have listener, we have separate endpoints for each required request. So it's just pretty standard experience API, nothing more. And then these requests are being redirected to the process layer. So what we need to do here, we need to add MCP bridge. MCP bridge will be added to the Omni gateway, and only for the API which is published to the exchange, because for the APIs which is not published to the exchange, it will be not possible to generate AI tooling without any RAML specification. You will see it why in one step. MCP bridge test, let's do it like this. So we will not change anything here. Okay, we have an MCP server running on the same path. I will delete it and create MCP bridge again from scratch. Demo API in MCP bridge test. Okay. Yes, so demo API will be used as the upstream API, but again, for now it's only one. Then it can be any variety of the data. And you see here we have all of the available endpoints from the demo API, experience API. But on the left side, you have AI tool name. This AI tool name were automatically generated from the resource name. For example, you see that for the updating team, we have put team's ID. This one was generated automatically by the MCP bridge. But also here we have a description which exactly showing to us what is the purpose of this endpoint. But this is not for all endpoints exists, and that's why it will be not possible to create this bridge. I will do it, and you see we have this error message like we need to fix these issues. And the issues which we have, that description is required. Why it required? Because we really need to get human readable description to the MCP just to understand how we can transform from human language to the resource language. And exactly AI tool name will help to do this. And if we don't have description, it will be not possible to generate or map accordingly this AI tool naming. So for our particular use case, I will disable these three. And for the last one, I will just edit the description, adding something like this. For our use case, it will be enough. So I'm pressing next and save and deploy. So let's wait a bit. And at this point, I just wanted to pay attention to the point that MCP bridge instances are immutable. So after an MCP bridge is deployed, you cannot modify, like you cannot add, remove these tools. If you wanted to change the tool configuration, you need to create MCP bridge from scratch. Also, if API published to any point exchange without RAML specification, then MCP bridge uses this auto suggest input schemas. So it's not really a good approach. So our MCP bridge is in progress to be added. Yes, so we have a consumer endpoint. It's an endpoint of the Omni gateway for sure, because it's tightly coupled with the Omni MCP bridge plus Omni. And quickly showing to you that we already, for the MCP bridge, have predefined policies which should be added by default, not only for the MCP bridge, but for the MCP connector as well. It's MCP support, schema validation, and transcoding router. So to test our MCP bridge, what we need to do, we need just to copy this public endpoint of the Omni gateway. I will remove MCP connector configuration from the cloud and try to add MCP bridge here. So Omni gateway and adding MCP path here. Okay. Okay, we have all of them here. So I will approve all of them, and going back to the plots, show me all, yes. Okay, and once this request is being executed, we can check what is happening directly in the experience API, because it's MCP bridge is on top of the experience API, not the MCP API. And in the logs, you see that just finding the tools. Okay. Yes, a few seconds ago, we are start processing, we're start getting players. You see this log message saying for us that everything is fine. And at this point, our demo is pretty finished. I'm passing the word to the Sergey.
Thanks, Artyom, and hi, everyone. Now we'll touch the point, what's better for us, MCP connector or MCP bridge, and choosing between both of them isn't a technical debate. It's a business decision driven by delivery timelines, existing assets, and the level of control your AI use case requires. But the real question is simple. Are you building a new AI capability or just exposing one you already have? And you should choose MCP connector when you are creating a capability that doesn't already exist as a MuleFlow or REST API, when you need deeper control over the agent, like input schemas, or as I already mentioned, error handling, when you need to implement authentication and authorization directly within the integration flow, and when you would like to leverage full MCP feature set like prompts. So once again, connector is the right choice when long-term maintainability, flexibility, and AI optimization are priorities. And you should choose MCP bridge when you already have production-ready APIs managed through API Manager and published in Exchange, as MCP bridge just wrap this API specification. When you need to enable agent access quickly and demonstrate value in weeks or even days rather than months. And of course, when rebuilding existing integration isn't justified from a budget or delivery perspective, when your API are already well designed and mapped naturally to MCP tools, and when you simply would like to validate business outcomes before investing in purpose-built agent integration. So summarizing, bridge is the right choice when speed and rapid adoption are the primary goals. But as Artyom already mentioned, the reality is that most organizations need both. For example, you can try out via MCP bridge, and later you can implement MCP connector as it's better for the long-term strategy. Artyom, could you please, yes, second slide. But AI agents introduce a new type of enterprise risk. And the question is no longer can we connect agents to our system, but the question is that can we trust them at scale? And of course, it starts with identity. Before an agent can do anything, we need to know who it is acting for and what it is allowed to access. That's why we have authentication and authorization, because every MCP tool can go through OAuth 2.0, so only authorized agents can access MCP endpoints, because OAuth controls are inherited automatically from the source API, and every MCP tool arrives in production safely without a separate review cycle. Agents act on behalf of authenticated users, not anonymous callers. Right. Once identity is established, the next challenge is ensure that every interaction follows organizational policies and compliance requirements. That's why we have policies, and we'll discuss them a bit later. There are 7 main MCP policies. And enforcing policies is only part of story. Enterprises also need visibility into what agents are doing, when they are doing it, and how they're interacting with business systems. That's why we can control them in any point monitoring, like rate limits, SLA enforcement, and full audit logs. Okay, and the last point is MCP server register, which allows us to share them via API manager, the same catalog where your REST APIs live today. You can apply policies and rate limiting just as you would do for any other API asset. Artyom, could you please go to the next slide? Thanks. As I already said, there are 7 main MCP policies, and I'll start from the default one, MCP support and schema validation. So MCP support provides the foundation for MCP governance by enabling a secure discovery and management for MCP server and tools to ensure that only trusted MCP capabilities are available to agents. And schema validation checks that MCP requests and responses follow the expected structure to prevent invalid requests from reaching the backend system. Other 5 MCP tools are MCP tool mapping, which controls which tools are exposed to agents and how they are presented to ensure that agents only see and use approved business capabilities. The first one is MCP attribute-based access control, ABAC, which applies access decision based on context such as user identity, application, or environment to enforce least privilege access, like agents receive exactly the permission they need and nothing more. MCP global access defines which MCP server and resources are available across the organization to prevent uncontrolled access and maintain consistent enterprise governance. The 6th one is PYY detector, my favorite, which identifies sensitive information flowing through MCP interactions such as text number, email, or any other custom PYY, which you can add to it to simply protect personal data and support compliance requirements. And the 7th one is payload optimization to reduce unnecessary data in MCP messages, to improve performance, reduce token usages, and lower AI processing costs. And together, all these policies are the guardrails needed to run agents safely in production with control access, protected sensitive data, validated interactions, and improved performance. Thanks. Now I'm passing the word to 𝐷𝐻𝐿 again.
Okay, thank you, Sergey. So I truly appreciate your time, guys, that you are still here. And I know that we are a bit out of it. So I will skip the migration roadmap as of now and switch to the latest part. It's really call to action. Like everyone who ever worked or currently working with the MuleSoft, it might be MuleSoft customers, should understand the main goal, that we are still trying to build the same integration, a structured, governed, and reusable. So experience API, process API, system API, it's still in place. And that is your competitive advantage. So the main goal is that the organization that will win in the next 3-5 years are not the ones that build the most sophisticated AI models. They're the ones whose systems are ready to be acted upon with those models, whose data is accessible, whose business logic is callable, whose integration approach is agent ready. You need to understand that you're closer than you think. And please pay attention for these 3 things that you can do at least this week. Because as you can see from the demo perspective, it's really a 1 hour method to run your MCP bridge or MCP connector. So the first one is open any point exchange and list your top 5-10 most consumed experience APIs. These are your first MCP tools. They already exist. They already work. Nothing should be changed. They just need to be wrapped, and that takes hours and maybe 1 hour, not weeks and not months. Write down your 5 you would want to be an AI agent call first. The second one, it's a bridge. Pick one of those API, for example, order API or customer API, whatever you want, and deploy MCP bridge on top of this API. Map 3 or 5, not even all of them, because you can configure it whatever you want. So map any of them to the MCP tools, and then just simply connect 𝐀𝐿 to or Agentforce to them. Run a live demo with your own team and show what autonomous looks like. Build the internal momentum that every transformation needs. And the last one, it's testing, of course, like connect a compatible AI agent to your new MCP server and give it a real business task. Then show this demo to your stakeholders, for example, because that conversation changes everything. And like in conclusion, the bigger picture, MCP is not a trend. It's really a new infrastructure. In the same way, like REST APIs became the default language of enterprise integration years ago. MCP is becoming the default interface between AI systems and the business capabilities they need to act on right now. So MuleSoft is the only integration platform that gives you both bridge for speed, connector for the control on the same anypoint platform you already operate. The governance, observability, exchange, cataloging, API manager policies, all of these following you to the agentic world. And you even don't need to have a newest platform. Just use the same anypoint platform. And the only thing you need is the additional and new layer on top of your integration, on top of what you have already. And just keep in mind that the future isn't API consumed by developers. It's tools consumed by agents. And your MuleSoft integration is ready to make that shift starting from today. So thank you, guys. We are waiting for the questions.
Thank you. Thank you, 𝐷𝐻𝐿. Thank you, Sergey. There are a couple of questions let me read them for those who are still with us. Yeah, thank you, John, for your feedback. There is a question: Do we have anything called MCP proxy? I heard it somewhere, but not sure.
So for now, for the high-level overview, there is no such possibility. But honestly, if we're talking about the proxy, Omni Gateway plus bridge itself, it's like a proxy. The same if we're talking about the MCP connector, which is running on top of the, not on top, but within the MCP connector. It's the same. A kind of the MCP proxy. That's why I truly suggest following firstly this type of available approaches, and then maybe if this not cover, then try different tools. But I'm not aware of it.
Okay, thank you.
Can you please repeat about that proxy stuff? I missed something in between.
Excuse me, I'm not really hearing you very well, so maybe
can you please repeat the term? Sorry, proxy one. Actually, I missed it in between. What is MCP proxy?
still some maybe issues with connection. Maybe you can type a question in the chat.
Yeah, Lakshmi, please type the question in the chat. And while you are typing, there is another question: Does MCP bridge support both RAML and OAuth?
Both RAML and OAuth,
Yeah.
just
OAuth.
different. Okay, OAuth. Yes, it's possible because MCP bridge, it's just a wrapper for your MuleSoft API, and MuleSoft API you can publish to Exchange either using the RAML stacks or OAuth.
Here's a question from Lakshmi. She just missed the explanation about MCP proxy. Will you please repeat?
Yeah, so again, there is no tool, at least from my understanding, called MCP proxy. Instead, you can use different approaches. Firstly, MCP bridge plus Omni Gateway itself, it's like MCP proxy. And the same you can do within MCP connector plus Omni Gateway. So maybe you can describe the real purpose of the MCP proxy, because for me, I didn't even hear something regarding the MCP proxy tool from the MuleSoft.
I see another question from the discussion with Vladimir, who left already answered, but how the agent discovers the specific one between thousands of others, and the specific one, I don't know, agents cannot understand the context.
But anyway, that's we have this type of the connection. Just 1 second. Yes, so we are writing a custom connector configuration inside our agent. That's why the list of available tools will be retrieved from the MCP server. And by doing this, we are establishing connection between the, in our case, Claude and MCP bridge or MCP connector.
Alexander raised as a hand. Please go ahead.
Yes, hello everybody. I have a very short question. The demo you ran, it was on a trail account, right?
Yes, exactly.
And it means on trail account now managed Omni Flex gateways also available.
Indeed, that's very good news, because before it was not available, but for now you can run only one instance of the managed Flex gateway on your trial account.
So it's still not enough to make a agent fabric demo, unfortunately, right?
Yep.
Okay, thank you. Thank you, 𝐴𝐿.
Thank you. Well, don't see any other questions, but still last minute to ask if anyone has anything in mind, any question. Great. Thank you very much, everyone who joined us. Thank you for staying with us a bit longer than expected. Thank you, Artyom and Sergey, for the great demo and useful information. And I'm ending the record. The record will be available with you shortly after the end of the session, as soon as I will have the processed records to share with you. Thank you, everyone. Have a good evening or morning or day, depending from where you're joining us. Goodbye.
Thank you. Thank you so much.
Thanks. Bye.
Have a good day. Bye-bye.
Thanks. Bye-bye.